Hello everyone, this is Jeff Krob. I'm the developer and programmer for WINGRIDDS Meteorological Data Analysis Software. This is a continuing series of tutorial videos that I'm doing to help you WINGRIDDS users out there to be more capable and more knowledgeable about what WINGRIDDS does and how it does it. This is video number 4. We're going to be covering the processing of observation data as opposed to the GRIB model data. This is the text or buffer based observation data. WINGRIDDS can work with that data also, and you can mix and match, and you can overlay, and you can compare the forecast model data with the actual observation data several hours later, and you can compare the two and see how well, use that as a tool to see how well the model data forecast actually matches up to the actual observation data. Going to the WINGRIDDS User's Guide, we're starting on page 37. And again, we're using WINGRIDDS version 5.13 for all of this. And so if this is several years down the road and you come across this, the user's guide may be modified a bit, so this may not be the exact page that it's on, but the information will still be there. But right now we're on page 37. It talks about downloading observation data. It's a quick write-up describing the different formats of the observation data that's available on the internet. And it says mainly broken up into two groups. ASCII-based text format, surface and upper air data like the METAR, the synoptic, the buoy data, and things like that, and then also the upper air data, the RAYOB reports. Those are all text-based information. And then the other main format is called buffer format files. And we'll peel away from this real quick to go show you, a lot of people may not have heard of buffer data. So let's go to the Wikipedia page for buffer. And buffer stands for, just like GRIB is an acronym, buffer stands for Binary Universal Form for the Representation of Meteorological Data, or buffer. And it is a binary format of data files which is used to concatenate and to combine together observations from specific points on the Earth, and it categorizes them all together and concatenates all these observations together into one file. And it also has what's called tables and built into the file to describe the information that's on there. So you can go all into deeper into the buffer format and things like that. But there's a lot of information on the internet about that. But WINGRIDDS can handle that buffer data. A lot of things that are buffer-based are things like satellite observations, not the imagery, but like the satellite sounding, satellite-derived winds. Let's see what else. WindSat data, and things like on the surface, like VAD winds, vertical atmospheric sounding winds, from NEXRAD radar sites, profiler data from radio and ultrasonic profiler sites that are scattered around. Well, all of that data is combined into these different buffer format files. And scrolling on down, there's a list of the data that WINGRIDDS can work with as far as the buffer data that might be available, like for the METAR. These are the actual buffer file names that you might come across on the internet. And like the VADWIN, Profiler, ADP-UPA, satellite winds, QuickSat winds, GOES, sounder observations, ATOVs, which are polar-based sounder data, and then any other files that you come across. Those are a slightly different format with the tables that I don't have access to, and so these are not available. So just something to keep in mind. Looking at the directory structure for WinGrids, observation data, there's a directory in WinGrids called obs. And if you go there, that's broken up into surface and upper air. And the surface has a directory called aviation, buoy, front, METAR, rad, ship, and synop. And the download scripts that WinGrids comes with will automatically stick the text files into those specific areas. One of the other things that I mentioned that WinGrids can do is the frontal position files. So these are all text-based, also put out by INSEP, and it's coded surface frontal positions. And so you have a parameter name, which would be highs or lows, troughs, and then the frontal type: stationary, occluded, cold, warm, and then the following numbers are the latitude, longitude points for drawing those features, whether it be a highs or lows or the stationary front. Those would all be the latitude, longitude points for the drawing program to draw the stationary front along those lines. And so that's what it is. I'll show you that when we bring WinGrids up. But I've downloaded already a simple example. I haven't done any buffer data, but downloaded some METAR data, some synoptic data, and then the other directory. You can get back in the upper air. Those are your RAOB observation, and we can look at that real quick. It's all texted, pretty much your TTAAs, TTBBs, TTCCs, PPAAs, and PPBBs, and all of those messages are all packed in there like that. And so WinGrids, along with the METAR and the synoptic and all the other text messages, all these things are all concatenated together. And so WinGrids will go through and parse through that the data and extract out the pertinent observation data and then store it. And then once it is concatenated, then it goes through the processes. It goes through the geographic area that you've selected to map that data to. It's usually referenced by a grid ID. I'll show you that when we come to it. And then it sees all those stations, goes through about what stations are within that geographic boundary of that gridded area, and then it collects all those stations for surface and upper air, and whether it be buffer or things like that. And then it goes through and does a Barnes analysis, which is a algorithm which takes randomly scattered points and then remaps and aligns it to organized gridded data points. And then it creates a WinGrids data file, which is very similar to what's created with the GRIB data for the model data, and then that's how WinGrids can use that. And then it saves all the text-based data that WinGrids can then reference for drawing station information, for reanalysis of, in case there's any, the data is corrupted. If there's a bad observation someplace, you can go in there and edit that data file to find that station that has the bad data, and then reprocess the data again to clear out that bad data. I'll show you an example of that I've created actually on my own to demonstrate that. But for right now, let's just go through the motions of the actual, we're presuming that the data has already been downloaded, and so we want to convert the observation data files. Like I said, today's the 27th, but the data that I downloaded was back on the 23rd. And if you notice, there's only a day of a month observations. WinGrids and the observations, or should I say, the observations don't have the full date time group for the month and the year and things like that. It's only the day of the month. And so if by chance you have old observation data in there and you don't clear it out before you download the new observation data and you process it, WinGrids is going to go through every file that it finds, new or old, and weed out the current observation data that you're looking for. Oop, backwards. We're on the 23rd. And then for the surface times, you have to tell it what time to look for, and the data is going to choose the current time that we're in, but I know that the data that I downloaded is for hour 12 for the surface, and also for the upper air, so that's 12. And of course, the surface data is every hour, so there would be 24 potential selections to choose from, and for the upper air, for the RAOB, it's only twice a day at 0Z and 12Z. There may be a special observation at 6 or at 18 if it's requested by INCEP or by the Storm Prediction Center, or locally where you may be, but traditionally it's just 0 and 12 hours. But you can pick any hour for the specific data file that you want to look for. The next is how you want to map the scattered random observations to a gridded data file so that you can actually do the contouring and things like that. This is where you choose the data, or the gridded perspective, should I say, to map the data to. I have it where it uses the INCEP National Weather Service predefined grids, whether it be the NWS grid IDs or the WAFS grid IDs. If you're not familiar with WAFS, there's already a tutorial number 3 which goes through and explains what WAFS is all about. Well, you could use that option here as well. But grid 211 is I believe off the top of my head, a 40-kilometer Lambert-Conant conformal grid centered over the continental United States. And so we'll just use that for this example. And for the observation data edit, we're not going to do that right now because there's nothing to edit because we're creating a new data file. And so we have all the information that we have, so let's go OK and watch what happens. Here's again the requested day, the requested time for the surface, the requested time for the upper air, the requested grid ID, and now it's going to go through all of those directories and find a file and go processing through that file. The times that you request right now is like you see, it's 12Z. There's a time window that's going to reject if the data is out of the time window, and I believe it's half an hour. It's 30 minutes. So anything older than 30 minutes from here, like our example 12Z, it will reject that observation. Also, it goes through and it sees if there's any repeat observations, like from the same station at the same time. It will reject any duplicate observations in there. So now we went through the METAR reports, now we're going through the synoptic reports, counting the stations that it finds of valid, unique observations, and now we're going through the upper air through the RAOB. So it's going processing through all those reports, looking for valid RAOB type reports for valid stations. If there's a station ID it doesn't recommend or doesn't recognize, it will reject that also. So here it's creating the gridded data, and everything's done. At the conclusion, if everything processed correctly, open up your data files and you will see here's our data file that we just processed for January 23rd of 2018, the surface of 12Z, the upper air of 12Z, and it was an observation type data file mapped to grid 211. That's what that stands for. Up here is an example of an observation for just surface only. If you just process surface data and you didn't process RAOB data, that's how that data file would look. Also, there's the option, like I said, the upper air data is usually only done twice a day at 0Z and 12Z, but of course the surface is supposed to be at every hour. You could potentially process surface data at like 18 or 17 or 16Z and use the upper air data of 12Z. So you can mix and match all of that as well. But we want to look at this. Again, we're looking at the United States, so let's PMSL. Let's look at the mean sea level pressure. And again, we defaulted our surface to 850 millibars. Let's go down to the surface at LDL SFC. So now we're at the surface. PMSL, that defaults to the pressure of mean sea level. That will plot that regardless of what level WinGrids is at. Let's overlay the wind, the surface wind. You can see the wind there conforming to the pressure contours. Up along the top, we have some extra icons that have come on the toolbar that have come active. If you have a data file that's open and there are surface observations to go along with it, this will, which means if it finds, you notice we saw our data file here. Well, in the OBS directory, this is the data file, text data file. Open that up real quick. It's over here to the side, hiding from me. This is the concatenation and the everything all thrown together of all the text base of all the surface observations and the RAOB observations, and if there were a buffer for satellite observations, for sounding, for wind, those will all be included in here also. But every station for the surface, whether it be synoptic or METAR, is in a 2-line entry. You have the 3-letter ID for the station, you have the ICAO ID. Not every surface station has an ICAO ID associated with it. Then you have the latitude, longitude. Then you have the elevation. You have temperature. You have dew point. You have the altimeter. You have the surface pressure. Then it goes through a few other things. Then you have the wind speed and wind direction. There's wind direction, wind speed. That would be that there. Yeah, so all of these are listed through here. Yeah, there's a surface station that has the ICAO ID along with it. And anything missing is called a negative 9999. That is a missing data entry. So that's what that looks like if you see that. That's what that means. We can scroll on down through all of the surface stations. And then we get to the, find that. We get to where the upper air, the RAOB observations are. These are split by this 4 stars and then 9999 all the way across there. That is what the WinGrids keys on to know how all this data is separated. So the next section, like I said, is the RAOB section. You have your surface, you have your station ID, your ICAO station ID, your latitude, longitude, elevation, and then all of the individual observations, the TTAA, TTBB, that were scattered about in the actual raw RAOB data, has all been grouped together here. The TTA is always first. These are the mandatory surfaces for all that were available for that observation. The next letter is 7, which are there are 7 entries that follow for this TTA section. The numbers on the left column, 64 reads that is the surface, and then 32 are the mandatory surfaces, like 1000 millibar, 925, 850. Then you have the heights above mean sea level. Then you have the temperature. Then you have the dew point. You have wind speed, wind direction, and then wind speed. The TTBB section, if you notice, there's a lot of 9999 in there, because the TTBB is reserved for significant temperature observations, and then the pressure level where that was at. And so at 943 millibars, you have negative 28.7 degrees Celsius, and then the dew point. And it lists all those. PPBB is similar, but is for significant wind observations. And instead of having the pressure level, it has the height level that wind observation that unique wind observation was recorded at. And so it goes all through, and that is one message. Not every station is going to have TTBB or PPBB observations, and some could be quite. There could be quite a few, and so that's something to look for as you go down within that data file. We'll close that out. We'll shrink that down, and since we're at the surface, like I said here, this icon on the toolbar is no longer gray, it is now dark. It shows that there are surface observations that you can view directly as a character, and so you can click on that and it will go through and it will draw the station representation for each of those stations that were listed in that data file. And that's where all of this information is obtained from. You have the precipitation, you have the temperature, you have dew point, you have the pressure, the sky coverage, the wind speed, wind direction, and things like that. Let's go up in the atmosphere some. Let's go up to 500. Go back to 500. So HHT/wind. So here's the winds and heights up at 500 millibar. And the same thing for that. We can do the overlay and look at those. And of course, these are just the stations where the RAOB was balloon was sent up. And so that's what that shows. And let's go back down to set LVO FFC. And we're bound to the surface. We can also, let's go back to PMSL/wind. Here's the wind and the sea level pressure. You can also overlay, like I said, those fronts. This is the frontal positions. Let's scooch over some so we can. And we can overlay the fronts again so you can get an idea how that works. There's a trough line, here's a cold front, an occluded front, stationary front, low pressure centers, and the low pressures, when there's a pressure center, the pressure of that low pressure is added along with the symbol. It'd be for high pressure also. One of the other things that we can display for the sounding, we can, since that RAOB data is there in that text file, we can view that RAOB data on a SKU-T, and also on the hodograph or whatever. But this information is only going to be available from the stations that send up the balloons. It's not like a grid point data like it was with the model data. So let's go to a station that I'm familiar with, KWAL, which is Wallops Island, which is over here on the eastern shore. Hit OK, OK. And so here is the RAOB from the balloon from Wallops Island. But all of the information is, just like a grid data file, is included in there. The winds, the calculations for the thicknesses and for the convective parameters, and wind shear and things like that. And again, here's the temperature, surface temperature. Something to look out for. Here's the -4 degrees Celsius contour, 0 degrees contour. I'm going to close this out and move in a file that we can simulate a corrupted data so we can show how to edit it and to make it correct. So let's Actually, we don't have to close it down. We can just shrink it down. Obs. Actually, yes, because we're on a different, just surface only. So let's close this out. We don't need that. We don't need that. So let's go into the temp. Here's our data file. So let's start WinGrids up again. And let's open up that surface file only. Let's look at the temperature of the surface. Hey, look at this. This is something that you would see if there was some corrupted data in one of the observations that didn't pass quality assurance or anything like that. So it actually made it out into the public, and so this is not representative of the real live weather. So what you can do to troubleshoot this, do overlay, you do the command stid to plot station IDs. See, let's zoom in a little bit closer. Let's see if that works. Type. Okay, you notice there's a station there, KEMP, which is right there at the center of the bullseye. So we suspect that has bad surface temperature information. So what you do in a situation like that, you go up here to the file, go back to convert observation files. You have to re-initialize it properly again. Let's go back to the 23rd where we're supposed to be. Back to hour 12, but this is only the surface, not the upper air, so we don't need that. Since we have the data file open, it's going to be listed here, and this file is what's listed in the obs directory, so we want to edit this. So we'll open up that data file. We suspect, we want to find, what was that station again? KEMP. Okay. Here's the station for Kemp. Here's the observation. Let's go across. We know that this is the latitude, longitude, elevation, and the temperature. Wow, the temperature is showing a negative 300 degrees. I don't think that's correct. If you notice the contours before, everything around it was more in the single digits, like -3, not -300. So we'll accept that as the edit. We'll save it. We will exit. Now we want to reanalyze the edited observation data. Go OK. And so let's look at that again. So now the error data, the bad data has been corrected, and now the contours are now correct once that bad data was removed. So this is what you can do with the observation data. And one thing, let's do the show the stations again. As part of the WinGrids functions of data thinning, it does an automatic thinning of the stations when you go to plot them. However, you can view everything if you want to. Let's do the full G command, which tells it to use the full resolution forecast data, also the full plot every station that's there. Don't use any automatic thinning. So let's plot that again and see. So there's a whole lot more stations that are actually used in the analysis than just doing the typical STID. Now to restore normal data thinning, the command is nrmg for normal grid. And we'll view the stations again, and there it does the automatic thinning. And there's the stations that go along with them. So that's how WinGrids handles and deals with observation data. I hope you find it useful and helps you be more knowledgeable in the observation or in the operation of WinGrids. Thank you very much. Have a great day.